Hello students, today we are going to start new unit, that is electromagnetic waves. In the beginning of this unit, we will study the complete description of electromagnetic waves. We will study the contents of electromagnetic waves and the sources of EM waves and what are its characteristics. And our main focus will be to solve the Maxwell equations and to describe the electromagnetic wave motion in different medium such as free space, lossless dielectrics, lossy dielectrics and good conductors. And we will discuss the power considerations, reflection and transmission between two different media. So in this way, in this unit, our main concern are these few topics. So we will start from contents of electromagnetic waves. So let us start from contents of electromagnetic waves. Electromagnetic waves consist of two things. First, it carries the electric field and the type of field should be varying, or we can say it should be oscillating. And the wave also carries the magnetic field and what type of magnetic field should be there? That is also oscillating. Okay, so these two varying electric and varying magnetic field moves and form electromagnetic waves. These moves together and they generate the electromagnetic waves. Let us see some observations. On the basis of that, we can say that electromagnetic wave consists the varying electric and varying magnetic field. So for that purpose, consider a conductor in which there is an electron, and if you will apply the electric field in any direction, the charge will experience a force opposite to that. And if you will apply the electric field in this direction, then the force will be experienced in opposite direction, like this. So it is obtained that when there is a conductor in which the charged particle is there, when waves are moving, it oscillates. That confirms that there is oscillating electric field, and due to that oscillation, the charged particle also oscillates. So it confirms that in a wave electric field is there. Similarly, when there is a coil and the wave is passed through this and EMF is induced in it. So that confirms that the EMF induced in it confirms the varying magnetic field. So in that way we can say the wave which is varying electric field and varying magnetic field is confirmed from the oscillation in the electrons and the EMF induced in it. So from there we can have that the wave has the varying electric field as well as varying magnetic field, and both of these varying electric and magnetic field moves in a direction. For example, it is x direction, it is y, and it is z direction. And here the electric field is 0. It is the strength of electric field with this electric field is with this strength. Here the electric field strength is this, and in this way the strength of electric field varies. Like this. So it forms an envelope like this. This is the electric field. It oscillates with different amplitude, and that is causing the oscillation in the electron. And similarly, the magnetic field is orthogonal to this, and that will be at 90 degree to this, and we can assume it like this. This is magnetic field, like this, in the z direction. This is magnetic field. Both are perpendicular to each other. This is electric field and this is magnetic field, and they are propagating in the direction of x, in this direction, and with the velocity v. And both these electric and magnetic field moves in the direction of x. And due to electric field, if the electron oscillates, and the number of oscillations in the electron in 1 second is the frequency of this wave. In this way we find the contents of electromagnetic wave is varying electric field, varying magnetic field, and these two fields are perpendicular to each other, and they are propagating in the third direction, that is perpendicular to these two directions. Now we will see how electromagnetic waves are created, that is the sources of electromagnetic waves. The source of electromagnetic wave is the electric charge, and we know that there are two basic characteristics of material. One is mass and another is electric charge. And mass is the characteristics which generate gravitational field, and charge is the characteristics which creates electric field around it. And the electric field around it depends on the movement of the charge. So in this way there may be three conditions. The first one is the charge is stationary. The second is the charge is moving. With uniform speed, or we can say just moving. And the third is the charge is accelerating. And according to the motion, there will be effects around it. So if the charge is stationary, in that case the electric field will also be stationary. So we can say here the electric field will be there due to the static charge, and that electric field will be stationary. And the second case, when the charge is moving, the moving charge creates electric field and magnetic field as well. One thing should be clear at this point: the current, moving current, does not creates electric field. It creates only magnetic field. Here the moving charge means the charge itself is moving. In a conductor, when there is flow of current, the net charge is zero. The flow of the net charge is zero. So in that case, the electric field is not created. Only magnetic field exists. And if charge is moving, like the charge in the bullet form, in that case electric as well as magnetic field will be there. And the third case, when the charge is accelerating, in this case it creates electric field as well as magnetic fields. For example, there is the charge Q. It moves with a velocity v, and at another moment the velocity increases and it becomes v plus some another v, and at next moment it becomes some another v, and so on. In this charge creates electric field, and this motion creates the magnetic field. And what's about the extra velocity that it has? And because of the extra velocity, there will be energy, and that energy pushes the E and B, and that starts moving, and its movement is called electromagnetic wave. Thus the source of electromagnetic wave is the accelerating charge. We can conclude at this point that the source of electromagnetic is wave is this. And the accelerating charge, the fundamental charge we can have electron. So the accelerating electron we can get in different situations. For example, if there is a sparking, in that case accelerated charge we can get. And so the accelerated charge can be obtained during sparking, and the LC circuit, and in LC circuit there is oscillations, and whenever there is oscillations the velocity changes, and due to that velocity there will be movement of the wave. And we can say the excited electron in the atom. Electron in the atom. When electron jumps to the next higher energy level and it comes back to the previous one, it oscillates with the extra energy. Due to that oscillations, the velocity of the electron changes at different moment, and that extra velocity causes the movement of the electromagnetic waves. In this way, wherever you will find the source of electromagnetic wave, you will find behind that there is a oscillating charge or accelerating charge. And in this way, these are the sources of electromagnetic waves.